There we go. Great. Okay. So, ladies and gentlemen, this category here includes those that are too risky to fix, too minor or to merit fixing, or those that you don't have time to fix. Why is it that you might elect not to fix a bug? I want to be very clear about this. That may sound perverse, that use a known defect. Why is it you might deliberately say we're not going to be fixing that anytime soon, or we won't potentially, anytime soon? Let's focus on that. Why not? Yeah.
If it's a minor bug and it requires a major restructuring of the system.
Good. Yeah. So the cost benefit is not worth it. Yeah.
It's a feature you might be getting rid of or something.
Yeah. So great idea, actually. I hadn't had that in mind, but that's exactly right. Yeah, so this is something that's on its way out anyway. That part of the code base is going to be tossed. It's just not worth it for us. Maybe it's little used, right? It's a feature that's used by very few people. It's only used in these sort of very special cases, and we don't have any customers who are needing that right now or what have you. Yeah.
It could be a bug related to some third-party library or software that you have limited control over, but rewriting your system to remove that library entirely might be unreasonable.
Good. Yeah, so it might have some external dependency that's just not realistic to get rid of, and again, you're willing to live with that. But there's a major class of issues that go beyond this, and they have to do with the uncertainty associated with fixing a defect. Help me unpack that. What do I mean by uncertainty associated with fixing a defect? What could be uncertain about fixing it?
It could have a domino effect on other code.
Could have a domino effect on other code. So attempting to fix this might in fact introduce other defects because it's tricky enough. It's a delicate enough area of the code base. You spend a lot of time getting it just right. You spend a lot of time eliminating some final bugs, a lot of time getting it in balance so that it actually works, and now you're going to go in and tinker with it when the deliverable is tomorrow? I don't think this sounds like a good idea. This might be a fairly modest bug, but we might introduce one that's really obvious. We'll do the demo in front of the client, and we'll have egg all over our faces. So there's very real reasons not to try to fix certain bugs. You leave them. Or if they're going to be fixed, you have a kind of team that is handpicked to study the situation really carefully, to oversee each other's work, and to very surgically and delicately try to fix the situation. And this is what teams will do. If there's a bug and they're close to shipping, they'll often do that. And I want to emphasize this issue of being close to shipping. When I say shipping, I mean putting the system live for clients, providing them with the system to run, getting it close to deployment. If you're an internal IT shop, do large-scale rollout across your firm. Why might it be particularly important to be worried about the risk as that date approaches? This uncertainty, why is that particularly important? As you approach the deadline, as you approach the delivery. Because, ladies and gentlemen, if something goes wrong, you might not have time to fix it again. But maybe more to the point, you won't have time to know that something went wrong because you don't even have time to test it thoroughly. So you are operating on a razor's edge. If you get something wrong, you may be rolling out blind, and there may be major issues that you're rolling out across your firm or you're rolling out to customers. So bugs, defects that are in the balance late in the stage when you're getting close to deployment are particularly worrisome, because if you try to fix it, you might not have time to have a second chance at it, and you might not even know that you've introduced a serious instability until it's on people's devices, on their desktops, it's out there on the web. Serious issue. So active bugs, the process of deciding which of them we fix is called triage, okay? And this triage team role is one that project managers, often dev leads, and often test leads are involved in working through this triage process. You're basically figuring out, okay, what are the most serious things here? What are the things we can act on? Given our limited time, what are we going to act on? What are we not going to act on? What are the battles we want to fight, and what are the battles we don't want to fight? Which of these are we really going to try to fix? Okay? So those bugs that are triaged in a way we decide we're going to take them on, then get assigned to the various developers. The developers work on them, and then they will mark a bug, a defect, as fixed or resolved. These are two terms for it, where basically they say, okay, I've resolved it. I've finished my solution to it. But that's not the end of the game. First of all, by so doing, by fixing it, there might be new bugs introduced. And so you really want to test after that to make sure, you don't just say, oh, okay, the system is down one less bug. No, in fact, there may be new bugs circulating because of those fixes. Realistic projects have fault feedback ratios of perhaps 0.1 to 0.2. What that means is for every bug fixed, or put it this way, for every 10 bugs fixed, there'll normally be one new bug introduced at least. And often it's much greater than that, two bugs. For every 5 fixed, you introduce a new one, or higher. For students, I wouldn't be surprised if it's higher. So this is a very real issue, and the problem is, if you introduce new bugs, it's going to take a while before they are revealed through testing, can be sanitized, can be triaged, and that may be time you don't have, right? Going back there. But when you fix it also, you don't necessarily take that as a given that it's fixed. There is then verification by the testing team or the original reporter that it is fixed, in which case it is marked as resolved. It's done. Case closed, okay? It's a closed, this would also be called closed. So it's a closed report. It's a closed situation, okay? So when we report defects, we often will report along with them a variety of types of information that will aid the assessment of these things, that will aid triage, that will aid sanitization, and aid in understanding of where this is. And what's very common are ones that you see here. The title, some short title, a priority associated with it. Is this a must fix? Is this a kind of opportunistic fix? Should fix, but as time allows and as circumstances permit it, or desirable to fix it, or it's improbable. And I want to distinguish that priority from severity. These are two different concepts within software development. Severity, we're talking about how severe is the bug if it materializes, if it comes about. If this bug occurs, what will happen? What do you think the worst thing that could happen? What's a bad thing that can happen? Crash. And there's various types of crashes, right? There's freezing crashes. There's crashes where it just bombs out of there. Just gone. Is that the worst sort, though? So that's very severe. That would be a top level severity. But is that the worst? Yeah.
It maybe depends on what application you have. So if you're a bank company, if you leak a bunch of credit cards or bank account information, that would be much more severe.
Good. Much more severe than just the systems going down. Is that information gets out, gets mailed to random customers. We have updated your PIN, such and such. Okay, what's another really bad thing? So security leaks, very good. I like that a lot. What's another really bad thing that can happen? Yeah.
Corrupt data.
Yeah, data is corrupted. So, it'd be really bad if you were working on a Google Doc or a Word doc and it bombed out in oh snap, you know, it gets, I think you've seen that before, right? Yeah. So oh snap, or Word just dies, right? Or freezes up, or OpenOffice freezes up. Man, you should have seen earlier versions of OpenOffice. They're pretty bad. So that's bad. But then imagine if instead your document just got scrambled in a really horrendous way, particularly if it's Word and you don't have a full version history or something. That's much worse. You've actually lost value. It's destroyed value. You know, one case it hasn't delivered value, which is bombed out. Another case it's destroyed what you have. And there's something almost transgressive about that. You know, this thing, it destroyed my information. And it's bad enough if you see that, but if you don't see it and it's just hidden, that can be just as bad. You know, maybe you're doing Peachtree accounting or, you know, some sort of accounting software. If it's corrupting the numbers in there and you don't know about it, in a way that's much worse. I mean, if you know about it, you can go fix it. If you don't know about it, it's much worse. So crashes are familiar hobgoblins in this area, but they're actually not the worst thing in many cases. Many data loss issues are really problematic. So severity is the badness if it comes about. Priority takes into account both severity and probability of occurring. It's a little bit like risk exposure. Do you remember risk exposure? Probability times severity if it happens. Same idea here. So priority is kind of the, you know, are we going to fix this? And it considers frequency as well as severity, the severity. But you want to have other information here too. The status, is this active? Has it been sanitized? Is it fixed? Is it fixed or resolved? Is it closed? And if it is resolved, is it fixed? Is it postponed? Is it marked as won't be fixed? Is it viewed as by design? This is how it's supposed to work, or what have you. Often you indicate if it's a regression or a regular bug. Is this something that's come back? Or is this something that used to work and no longer does? So for regression, we basically used to be okay, and now it's bad again. And then, you know, the area of the project, who opened it, and very critically, a formula to reproduce it. You need to, if you're reporting this bug, you want to say, how do you get there, right? Person assigned to. And who reported it, who's it been assigned to. These are two different people typically. Person reporting may be someone that the person who has it assigned to them wants to talk to find out exactly how they reproduced it. So defect tracking. And, you know, if you go to Bugzilla, or you go to, maybe someone could open the door there. If you go to Bugzilla, or you go to, you know, Redmine or Jira, or you go to GitHub's issue tracking, you'll almost certainly be able to record things like those there. And those are just very common in bug reporting systems. Okay, how do you create a good bug report? Well, maybe it sounds obvious, but it's not. You do structured exploration, you try to reproduce it, isolate it to make it as simple as possible. Figure out, you know, if it's general, if it's not just this particular case, but in general. You know, see if it existed in a previous version. How far back does this go? Is this just the very latest version of the software, or did it occur in the earlier ones, we just didn't notice it? That's really helpful to track down where the problem came in, right? If it was in earlier versions, it could be in a lot of different places in the software. If it's only the latest one, then there's only so much that changed. We can track it down more easily. Try to summarize it, condense it, neutralize it in terms of not making it, you know, deliberately poking someone, another one of your bugs again, something like that, and disambiguate it. Some people review these, you know, have someone look it over just to see. The goal here is to provide a bug report that can be read by someone understood well, allowed them to reproduce it, and they won't get defensive about it, and they'll seek to act on it. Okay, reproducing bugs. A key principle here is you want to make a copy of any data that can be destroyed or modified by it. If in reproducing it you lose the data that was there in the first place, it may be hard to reproduce again. And if you're doing exploratory testing, try to jot down something about what you're doing. Maybe record the session if you want, but have some way of tracking down how you got there. And a key element here is you prepare, but at the end you restore. You restore any information that you need. Now, reproduction of defects or the failure, it's not an easy thing. And in my lifetime, I've struggled occasionally. Maybe every few years these days, I'll work with a bug that's it requires many hours to reproduce. I remember, as a professional software developer, about the worst it got is there was a bug that took me about 1.5 days to reliably reproduce. It was a bug which would disappear when you used the debugger. It was a memory-related bug in C. It was what we call a Heisen bug. So once you start trying to study it with tools, it would disappear. And it took a lot to try to reproduce that. And there's a lot of problems that can occur that will get in the way of reproducing the bug, the failure. Race conditions, things that have to occur at almost the same time, and how it turns out depends on which of them occur at what time relative to the other in very short sequence. Forgotten external details. You forgot that you had disconnected that network plug earlier, or you had earlier you had a crash in another software application or something related to that it did something intended and forgotten. The bug's changed the state, so it's no longer in the same state, so it can't be reproduced without rolling back to an earlier state. In C, C++, these are big issues, fragmentation of heap. The heap has to be in a certain state to see the bug. It's a loose pointer issue, or an issue with double free memory, or with memory leak, or what have you. Cascading failure, one failure causes another, and you only see it in that case. Time dependence, it depends on time of day or circumstances. We deal with these sort of things a fair bit because we have global customers, and something that works in this time zone sometimes shows issues there. Just a few weeks ago, we had issues with GPS data. It was inaccurate west of 100 degrees west latitude. And because so many of our tests had been east of that, we didn't notice. But it lost accuracy there. And it turns out it was due to encoding in decimal of a certain certain thing, and the extra zero got dropped. Resource dependence, so it's dependent on some resource which varies, hardware, etc. Software is, blaming hardware is one of the last things you want to do. Typically it's not hardware, and software engineers love to blame hardware. It gets them, it must be the hardware. Occasionally there are, it's an analog world, ladies and gentlemen. I had one colleague here at the U of S. I do a lot of debugging, but I normally forget to record my debugging stories. But this one stood out in my mind. There was a colleague here whose office was opposite mine. He's no longer on the faculty, he's retired. But he was involved in implementing a game for Wanniskewin. Okay? Wanniskewin, I don't know how many of you have been there, probably quite a few, but they used to have they've restructured it, but they used to have a hall where you'd go into, and there were a bunch of artifacts there. There was a early sort of pre-TP style, of canvas TP. It was a buffalo hide structure there, and they had animals of the prairies, and they had stone tools that were built early on, and they had fire making equipment, and bows and arrows, and some atlatls or what have you, some various tools. And so they wanted to commission a game, and it was called Buffalo Hunt. So they asked this professor as a contractor to his company to build them this Buffalo Hunt game. So they built the game, and it was basically a computer that was there, a dedicated computer, which was running Buffalo Hunt, and you would interact with it with a touch on the screen. And so people would come in and they'd say, okay, I want to go on a buffalo hunt. How do you know, what's your strategy for hunting the buffalo? You know, I'm gonna try to, you know, stick them with a spear. I'm gonna try to run them over a cliff, or I'm going to run them into an enclosure and trap them there. I don't think they had horses in it, so it was pre-reintroduction of the horse in North America, so pre-Columbian contact. In any case, they had this buffalo hunt game, and it worked great. They went through testing with it. It was working great. So they deployed it at Wanuskewin, and they got a call after, you know, a bit of ceremony to deploy it, and people using it there, being happy with it. They did it, and I think a few hours after deploying it, they got a call, and it said, the game's not working. I said, okay, so what's up? They said, well, it's just frozen. So I went over to Wanuskewin to look at the situation. It was hung there. So they kind of poked at it. They engaged in frothing behavior to no avail. So they rebooted the computer, and it came up and it worked fine. But that's kind of weird. Looking good now. Who knows? Maybe Murphy's Law. So left it again. A couple hours later, the game's not working again. This kept on going on. It went on for days and even weeks. And Wanuskewin folks were not so happy with this. You know, they had to keep on calling these contractors. A lot of people wanted to play the game and they couldn't because it was frozen. You know, and it wasn't because it was merely winter in the game. It was genuinely frozen from a computational and a silicon sense. So the guys, you know, tried to reproduce this back in their lab. They at their company, they were running the game, and they were just wailing at it, trying to reproduce it, trying to do all these things to make it crash. And they were dealing with very limited reports on it. Maybe it's when multiple people touch it at the same time, or several fingers. They could not reproduce this thing. After hours and hours and hours, they could not get it to crash this way. And so they're absolutely mystified. And as a lark, they decided, okay, or as a last chance, they decided, okay, let's go ask Wanuskewin, can we try to observe one of these crashes by our own eyes? Maybe even record it. Well, yeah, it's going to be very labor intensive because it only occurs once every few hours, but sure. So they went over and they stood in that room and watched people go up and interact with the game. And this went on for hours, and it was working fine. Until, you know, one person came into the room, and they seemed particularly interested in the things in the room, and they came over to the game, and the first thing they touched it died. It crashed. Okay, so that's good. So they rebooted it, and then they have to wait more. It's like a hunter, right? You're waiting for the prey. You're waiting for the rabbit to come by. You got the spear, and you're just waiting for it. So you got to be patient. You got to be observant. So they waited and waited and waited. This, I think, it occurred over like 2 days. They were just waiting there, waiting for it to happen, and trying to observe what happened. And they noticed a commonality. Basically, when it would happen, it was people who were spending more time in the room, and they particularly were interested in exploring the buffalo hide structure. They would go into the buffalo hide structure and then come over there. And they realized that, some of the people, when they go over to the buffalo hide, they rub the buffalo hide. And they get charged up with static. And then they come and they press, they want to do the buffalo hunt. They're all fired up, you know, where they get them hides from. And so they press the buffalo jump and it dies. So it's just the the customers you want, right? The ones who are fired up about the buffalo hunt. And it died. So then they said, okay, now we can reproduce this. So they went over and rubbed it up. they went and touched it, boom, dead. Reproduced it like 5 times in a row. Okay, now we got it. So they put an anti-static map. And they put it at the bottom. Never happened again. Never happened again. Ladies and gentlemen, we are computer scientists. A few of us, perhaps, in this room are electrical engineers as well. And we live in an analog world. And sometimes it rears its head. And static is one of those things that can't happen. I had a colleague who told me he was changing a board in his computer. He saw a little fireball come out because of the static. And I've certainly seen myself discharge. I'm not like Zeus with firing thunderbolts, but I've seen myself discharge static. So if you will notice, it's an odd habit of mine, but you'll notice it, and you'll notice with Kevin Stanley, who's also an engineer, when we do things in our offices, like touch computers and so on, you'll see us reflexively ground ourselves. So we'll ground ourselves against metal in our offices. And it's not a nervous tick. It's because after so many years of burning things out, frying chips, and notice, okay, it's because of that. It's because of static, ladies and gentlemen. So, problems with reproduction. Static from buffalo hides. And it's not merely from buffalo hides. Okay, so we're going to stop there. The hunt is concluded for today. I hope you don't have a frozen weekend. And I hope that the recording worked. Perhaps the microphone died from static discharge. Thank you very much.